In both societal consensus and clinical science, human aging is universally classified as an inescapable process of biological loss. When an individual paints their most innovative work in their 70s, like Joseph M. W. Turner, the medical community categorizes them as an anomaly. When Diana Nyad swam 110 miles from Cuba to Florida at age 64, her physical achievement was written off as an extreme genetic exception to the established rule of decline. This assumption of inevitable loss is formally codified into global health policy by the leading authorities in geroscience. This standard clinical chart tracks intrinsic capacity based on the World Health Organization's ICOPE tool. The protocol limits patients to exactly two states, stable or in decline. Because the y-axis is intentionally truncated, it is mathematically impossible to record an upward trajectory. Clinical models are structured to forbid the measurement of improvement. Consequently, the medical field cannot see functional gains in older populations, even when they occur. In 2026, researchers Becca Levy and Martin Slade published a study utilizing a measurement scale that allowed for an upward trajectory. They drew their data from the Health and Retirement Study, a gold standard longitudinal cohort of older Americans. The dataset tracked over 11,000 participants across a 12-year period. This massive scatterplot maps the trajectories of those 11,314 participants. Over 12 years, 45.15% of these individuals recorded scores that moved above their baseline. Broken down by domain, 31.88% improved their cognitive capacity and 28% improved their physical capacity. Traditional aging research averages the health outcomes of an entire cohort over time. That mathematical flattening obscures the subsets of people who are actively gaining capacity. When the heterogeneity of an aging population is preserved in the data model, strict biological decline ceases to be a universal rule. Extrapolating that 45.15% to the broader U.S. population reveals the human scale of this phenomenon. Today, 26 million older Americans are currently experiencing an upward health trajectory. Nearly half the aging population defies the clinical assumption of inevitable loss. Upward mobility in late life is a documented biological reality. The immediate clinical objection to these findings is that cognitive gains are merely practice effects from repeated testing or statistical noise. To address this, the researchers relied on two hard biomarkers. Physical capacity was measured by walking speed, heavily correlated with longevity. Cognitive capacity was measured by TX, a 27-point clinical interview evaluating short-term memory and mathematical skills. To neutralize practice effects over the 12 years, the study utilized 4 entirely distinct, non-overlapping word lists during the cognitive evaluations. They isolated participants whose scores changed by less than 1 cognitive point, or 5 centimeters per second in walking speed, and deleted them. Even after this aggressive statistical pruning, the upward trends remained robust. Over 22% improved cognitively and 26% physically. For context, the U.S. Department of Health's Healthy People 2030 target aims to increase positive health outcomes for older adults by just 11.5%. Because the improvement data survives the harshest statistical stress tests, the field must identify the causal driver behind the gains. The investigative question becomes, what independent variable is powerful enough to drive measurable physiological improvement across diverse demographics? The regression model controlled for systemic factors, medical history, and genetics, including the APOE epsilon 4 marker, a genetic variant strongly linked to Alzheimer's disease. The specific modifiable variable that successfully predicted the upward trajectory was positive age beliefs. The researchers quantified this subjective mindset using the Philadelphia Geriatric Center Morale Scale, a standardized psychological tool measuring an individual's attitude toward their own aging. This split-screen bar chart compares physical improvement between groups holding negative and positive age beliefs. The positive belief cohort demonstrated an 11% higher likelihood of physical improvement and a 6% higher likelihood of cognitive improvement. Conversely, the cohort that internalized negative age beliefs matched the expected baseline of continuous physiological decline. The predictive power of positive age beliefs remained statistically significant even after adjusting for all other physiological covariates in the model. A culture-based psychosocial mindset operates as a hard, statistically significant driver that is fully capable of altering physiological outcomes. A final clinical counterargument suggests that this measured improvement is strictly an impaired patient recovering to their previous baseline after an illness or injury. To test this, the researchers ran a second sensitivity analysis, focusing exclusively on participants who entered the study with zero cognitive or physical deficits. This scatterplot isolates the baseline normal cohort, individuals starting with a cognitive score greater than 12 and a walking speed faster than 60 centimeters per second. Over the next 12 years, a significant portion of this healthy group pushed their scores higher on the y-axis, extending past their original baseline capacities. Specifically, 27.7% of these healthy individuals achieved sustained cognitive improvement, and 23% improved their physical capacity. This upward mobility in healthy individuals indicates that improvement is not merely rehabilitation from disease. Positive age beliefs activate a latent physiological reserve, pushing individuals beyond their established baselines. The mechanical framework explaining how a subjective thought becomes a physiological outcome is known as stereotype embodiment theory. This diagram illustrates the feedback loop. Societal clues regarding age are internalized over a lifetime. When those internalized beliefs are positive, they alter neurological output, which increases the individual's self-efficacy, directly leading to further health improvement. Past studies show that the internalization of negative stereotypes correlates directly with documented Alzheimer's biomarkers, specifically the accumulation of plaques and tangles in the brain. The Levy and Slade study introduces the inverse biological reaction. The data suggests that positive age beliefs actively promote the regeneration of neural connections in the brain and satellite cells in the muscles. The clinical definition of accelerated aging currently equates aging exclusively with decline. That definition requires immediate structural revision to include patterns of stability and improvement. Preventative services and rehabilitation protocols must also be updated to account for the mathematical probability that an older patient can increase their intrinsic capacity. Geroscience must abandon the binary of decline. By redefining the aging process, the medical field can begin treating age beliefs as a biological variable capable of redirecting the human trajectory.